This lecture is on turfgrass selection and irrigation practices. I'm your speaker, Alec Kovaleski, the turf specialist at Oregon State University. Today, I'm going to share with you some turfgrass selection and irrigation practices research done at Oregon State. And first, we're going to look at turfgrass selection. So, to do this, I thought I would share with you how to find National Turfgrass Evaluation Program data collected in Oregon, Corvallis, Oregon, on tall fescue, fine fescue, low and pit cool season grasses, and perennial ryegrass. So to find this data, we're going to take a little trip to the National Turfgrass Evaluation Program website. Okay, this is going to be a quick overview of how to find NTIP data online. So I'm going to go to Google here first. I'm going to search NTIP for National Turfgrass Evaluation Program. The first link I get is this www.ntip.org or the National Turfgrass Evaluation Program welcome page. I click on there, it takes me to the entrance of the NTIP website. If I scroll down to the bottom, I click on this red button here that says, if you agree to the above statement, click here to enter. So let's go ahead and click and enter. And now we're into the NTIP website. And the way I like to access the data is I come across the top here. You've got About Us, Latest Data, Previous Data, and State Data. Let's go ahead and click on State Data. For turfgrass managers in the western part of Canada, one of your best options for local National Turfgrass Evaluation Program data is going to be in the state of Oregon. So I'm going to come down to Oregon, I'm going to click on that, and you're going to be looking at data from the Corvallis site, which is about 45 minutes in from the Oregon coast there. So probably very similar to coastal environments in British Columbia. Okay, so we've got NTIP data on cool season, low input turf grasses, fine fescue, perennial ryegrass, and tall fescue in the state of Oregon. In this particular instance, I'm going to click on the link to the perennial ryegrass data. That's going to take me to this page here, which is the perennial ryegrass 2018 report. This was the last published and then uploaded report on the NTIP website. And this is the Corvallis, Oregon data only here because we entered into this report from the Corvallis link here. So if I click on this top right part here, 2018 data, I will see the 2018 results collected from Corvallis, Oregon only, okay? And across the top here in the first column, you see genetic color here, and then on the following columns, you see turfgrass quality from January to December, and then a mean turfgrass quality rating on the far right. And NTIP data here is ranked from the highest mean in the far right, so that's the best quality possible in this study, up here at the top, and it scrolls down, and as you go down through the table, you see that the mean quality gets progressively worse till you get to the very bottom, with Lynn perennial ryegrass having the worst mean quality in this data set. Okay. Now let's move on from turfgrass selection over to irrigation practices. And to discuss this point, I thought I would share with you a recent publication produced by Oregon State University. We're looking at the water requirements influenced by turfgrass species in Western Oregon. And you can find the original publication at Crop Forage and Turfgrass Management. It's an open access journal, so it's free access for anybody that wants to see this information. Okay, so the objective of this project was to evaluate the effects of cool season turfgrass species on irrigation interval in Western Oregon. So for this project, we had 9 different turfgrass species: Kentucky bluegrass, creeping bentgrass, colonial bentgrass, velvet bentgrass, perennial ryegrass, tall fescue, and then slender, creeping red fescue, chewing fescue, and strong creeping red fescue. And some other methods and materials used in this project. We maintain the turf grasses in this project
at a 2-inch height. Turfgrass was assessed daily for drought stress. So when drought stress was observed, irrigation was then applied at 0.3 inches. Okay, so the turf was regularly assessed and then irrigation was applied to prevent drought stress from getting any worse, and reapplied when observed again. Okay, so here we are now looking at results from this project. And what you see in this table here is on the left is the turfgrass species. And in these two columns, these numbers represent the interval between irrigation events. Okay, so starting at the top, you have the turf grasses that needed the most frequent irrigation, which were strong creeping red fescue, slender creeping red fescue, and chewing fescue. So these grasses needed water about every 2 days to prevent drought stress from setting in. Okay, this was then followed by colonial bentgrass, velvet bentgrass, Kentucky bluegrass, and creeping bentgrass. So these grasses needed irrigation about every 3 days to prevent significant drought stress from setting in. And then some of our grasses that could go the longest between irrigation events without showing drought stress concluded perennial ryegrass, which could go about every 4 days, and then tall fescue, which could go every 4 or 5 days without having drought stress when irrigated at 0.3 inches per irrigation event. Okay, so that concludes our quick summary of turfgrass selection data and irrigation practices at Oregon State University. If you want more information on these projects, you can contact me, alec.kowaleski, KOWALEWSKI, at oregonstate.edu. Thanks, and I hope to talk to you all again soon. See ya.